Hi, welcome to week 5 of 2025. This is the week where we talked about functions in depth. We started last week, but we're finishing up this week and we're about to move on to some new stuff. And so I had a quick review of how to do function sort of puzzles. This is not the real skill. This is related, but the real skill is going to just take you sitting down and practicing. Functions are tricky to work through. You have to think in some weird, kind of abstract ways, very kind of indirect. And it takes a while because you have to think fairly far in advance. Like it's kind of like just learning to play chess further moves out than you're starting on. You have to be planning for these kind of deeper interactions. But, part of that is learning some of the basics. So let's study that a little bit. This first question is just trying to get y'all to grapple with this concept that often is confusing to students. They don't really get why some data comes out of the function and some data doesn't, and that's all very confusing. And so I have one big tip, and the one big tip is just always use the return function to choose what data to return. Now, if you don't want to return any information, then you don't need it. But most of the time when I'm doing a function, I have some inputs and then I want to structure them into some sort of output. Now there's a lot of ways to output data from functions, but return is pretty straightforward. Whatever you put as it, didn't need to do that. Whatever you put as its argument, that's what gets returned to the user. And then additionally, it exits the function. And so it just allows you a pretty fine level of control over what's coming out. And that turns out to solve a lot of questions students end up having. One of the caveats to that, though, is that sometimes students will add prints, which are great. That allows you to see what's going on the inside of the function. However, it can be a bit confusing. So let's go through a few examples. So first I'm going to create this function. So now this function is in R, I can use it. And so this first example is asking what will be printed when I run the line of code I've currently highlighted. Now, for the record, all of these show the function itself. Well, the function doesn't print off anything when you run it just by itself. This is not me using the function. This is just me storing this code inside the object. It's not until I run the function does anything from the inside actually happen. So what I'm doing here is I am passing it a single value. That single value is argument 1, which is argument x. I'm passing it the value 1, and that means that on the inside of the function, x will become the value 1. It then gets printed, and so printed. It prints the value 1. It then returns 1 plus 1, so it's going to return the value 2, and then it's going to assign that value to object out. Now, just what I've highlighted by itself, you won't see the 2. It's in there. So when I run this, first I have to click on it. When I run this, I see that printed 1. That's from this print right here. And that's all that's printed because the returned data was stored inside of out. It's like you think of it like a tangible thing that's being passed around. The data that was inside of x plus 1 got passed back to the user, but then the user placed that in object out. Now, in this next example, I do that same process, but then I say the word out. And just to track this through again, here I call fun A. I give it a single argument. That single argument is the value 1. Because there is only one argument, that value becomes the argument x. And please note how I kind of said that. Maybe make to practice that on your own. Like that is kind of how you would term a lot of this. Anyways, that 1 becomes the argument x. X is then printed, so this is going to print out 1. And then it's going to return x plus 1, so it's going to return 2. And it's going to assign that to object out. But then this code includes, then I just say out by itself. And when I do that, and I don't tell R what to do with the data that I've invoked, it prints it. And that's just kind of how R does. In like interactive code, when you just say an object's name and or you just produce some data and you don't tell R what to do with it, it just prints it. Because what else is it going to do with it? You're not assigning out to some to some other function. You're not assigning it to a new object. You're just saying out. And so the behavior that R defaults to is trying to print it, at least for most objects. It does turn out that there are other objects that don't have that as their default. Additionally, that's not always true. So for example, had I just said x plus 2 inside the function, you'll note it did not print 3, and that's because inside of a function, it does not default to printing. Additionally, inside of a for loop, it doesn't default to printing. I think let's just do a little if chunk, and we'll just say out inside there. And we're going to find out if when I run this, does it print out? It does. So that one it does do. So for loops, no. If statements, yes. And functions, no. Do you need to memorize that? No. In the end, like, you do what I just did. I legitimately couldn't remember. I was pretty sure it did print it, but I honestly was not 100%. And in the end, who cares? Just run it. It takes like 3 seconds, and you use that as needed for your coding experience, and then you move on with your life. And that's kind of the beauty of coding, is it's just a lot of little tiny puzzles, and really they don't mean a lot in the long term. You just puzzle them out as you go. Okay, I'm getting too philosophical. Let's do this next question. The next one is, if I don't assign that data, what is going to happen? Well, again, running through it, this time, same as last times, I am going to assign the x argument the value 1, and so on the inside of the function, x becomes the value 1. That then gets printed. X plus 1 is then returned to the user, so I now have the value 2 after running this, but this time I don't tell R what to do with it. And so what R defaults to doing when I don't tell it what to do with the data is it tends to print it. And that's exactly what will happen. So I will get 1 printed from the inside of or from what the function does. And then afterwards, because I have this unassigned data, I get 2 out. Okay. Again, not super realistic, but they are realistic questions that come up, like when you are writing code. And hopefully that was some decent practice. Now, this next one is, again, kind of confusing, but it's practice of setting arguments, because that turns out to be its own little battle. So let's talk about that. So here I have a couple of different scenarios. Each scenario starts the same way. I have a function called funB. I have a value on the outside called y, but I also have an argument on the inside of the function called y. And the real trick to these is those y's have nothing to do with each other. They can be set equal to each other, but they otherwise don't have anything to do with each other. So you have to separate this, that the point of a function is to help you isolate a process, to avoid like cluttering up your environment and all of that good stuff that keeps us nice and organized. So when I call this funB of 5, and we think through our argument settings, well, the arguments that are unnamed, and this is currently an unnamed value, get applied based on order. Well, the first argument that the user hasn't already specified here is x. And so x becomes the value 5 on the inside of the function. Y becomes the value 4 because that's its default, and I didn't overwrite that default. So I now have 5 plus 16, and so 21. That's it. 21 then gets returned to the user, and because that is an unassigned output, it gets printed. And so that's your answer, 21. Next up, I got these out of order. I'm sorry. There we go. Next up, we've got y equals 2 as one of my arguments. So that's going to overwrite the default value here. Please note that is the order. And that is, I think, a legitimate confusion students might have, is that this is just kind of something you have to memorize. That the order for argument setting is the name of the argument on the left and the value you're assigning it to on the right. Just like with assigning objects, the object that you're assigning to goes on the left, and the values that you're trying to store inside of that go on the right. The object inside the function, so the argument, and the values I'm trying to assign it. So here, that's going to overwrite the default value of y. And then I have an unnamed argument. And please notice if you just think through what I just said, this is an unnamed argument. The name always goes on the left of an equal sign. Well, there is no equal sign here. This is therefore just kind of the value y. Well, the value y on the outside of the function is 10. Having nothing to do with this y, having nothing to do with this y. This is just an object on the outside of the function. So this becomes the value 10, or it is, I should say, the value 10. And that's going to be applied to argument x. And that's just based on those rules of assignment, based on the order of the arguments. So again, convoluted, more convoluted, and really the point of this is just like giving you an example of why you shouldn't do stuff like this. Don't name your arguments the same name as objects on the outside. It's a cartoonish example, but it's a real example. And when you're writing functions, it turns out you're often going to come across the problem of it's kind of hard to name objects good names. And this is a thing to avoid. Try not to name them the same thing. It just gets confusing. But anyways, to answer the question, y is the value 10 when it gets used to make the value x. And so this becomes 10. This default value has been overwritten by the user when they said 2. So that is 10 plus 4, or 14. Next up, this one is just y. Again, this is an unnamed argument, and therefore this is just the value y. The value y is 10 on the outside of the function. That 10 is then going to be sent to the x argument. So that's going to be 10 plus 16, or 21 again. We could keep doing these if we wanted to. You can also play with them yourself. Like if you wanted to know what happens if I do y equals y. And I think a fun little practice is to note this one's going to result in an error. Please figure out why. 5 seconds. I kind of enjoy doing this. It's weird. Okay, the reason this is going to result in an error is x isn't set. So here I have y has been set as 10, but there is no x. If I do this, this is a good question, actually. I like this one. What is this one going to be? Hope you got that one. This is going to become, this is the value 10 being set as y, so that's 100. And then this is going to be assigned to x, so that becomes 10 plus 100. Let's do another one. Y and 7. Let's do 8. So here I have this setup. This one, neither one has a name, which means they're purely set based on order. And so that means this is going to become the value used as x. So that is 10 plus 64. 72. I don't know why it says 72. That's it. So anyways, you can play with these on your own. Just make sure you are asking questions. The key thing is recognizing when an argument is named versus when it's not named in conjunction with memorizing those rules. Finally, the big thing with these 3 questions was recognizing that there is a difference between objects on the outside of a function and objects on the inside of a function. There is a huge caveat to that, and that is if you kind of mess up and you forget to make one of your inputs. So now I am never passing any object called y to fun_b. And so it's managing to find y from the outside. In this situation, because I haven't told it what y should be, it's exiting the function and finding that y from my global environment. And this is actually, I would say this is my 100% my least favorite behavior of R. I know why it does this, and it makes a lot of things more simple because it does this, but I will also say, just as a teacher, it makes it much more confusing to students. And I personally have been tripped up by this quite often. And it's why you'll often hear me talk about whenever you're done writing a function, you should be clearing your environment, running the function, and testing it again. Because when I did that this time, because I never ran this line of code, without that line of code, the y doesn't have anything to pull from. And so before, when I forgot, like if I'm pretending I just forgot to add y to this, by removing it from my global environment, I'm revealing that that could have been the issue. This is hugely problematic. It will happen to you. It happens to me all the time. Now that I watch for it, though, I'm much better at just catching it before it's a problem. And it's through this method of clearing my environment, running the function, and then if I need to, making a little bit of test data to play with, but as little as possible, because I really want to test this from as clean of an environment so I don't get confused on where this data is coming from. But anyways, that's the end of my video. I hope that helped. Let me know if you have any questions. Bye.